In this lab, at the moment, R1 and R2 are peering with only one external autonomous system, which is 100. So we have only eBGP peering here. Let's see what happens when I start peering with another autonomous system, because there's a very interesting situation where we are by default becoming a transit autonomous system. So what that means that we're going to be advertising towards external autonomous system something we are learning from another autonomous system, and that is a situation which we try to avoid unless we are a very large autonomous system, part of the internet that is actually a transit AS. So we need to filter out what we're advertising, but let's see that situation happen first. So what I'm going to do now, I'm going to create a peering between R1 and R3 with AS30. Let's go ahead and do this here real quick. So conf the router BGP 500, my neighbor is 10.1.13.3, and it's in remote AS 30, and I'm not doing anything else. I'm not doing any filtering of any sort. So if I go back to R3 and I create a peering with this guy as well, so I'm gonna say router BGP 30, and my neighbor is 10.1.13.1, and remote AS is 500. So shortly I am going to have a peering between them. So let's see that happen. It's up. Show IP BGP summary. And currently there are two peerings with external ASs. This is peering with AS100 and this is peering with AS30 as seen in the output. From each one of them I'm learning 6 prefixes, but let's see what happens. So when I get, let's say, prefix from, let's say, AS30, let's just filter those first in show IPBGP. Let's go for regular expressions learned from, originated maybe by AS30. So this is originated by AS30. And there are 2 prefixes I am receiving. 133, 133, 10, and 20. Show IP BGP summary. If I ask my router now what am I advertising towards AS100, show IP BGP and neighbor 10.1, 10.254, advertised routes. So I'm asking my router, what are you advertising towards AS100? What I'm going to see that I'm advertising something I learned from AS100 right here, and I'm advertising something that belongs to AS30. So that I am now becoming a transit autonomous system, something I want to avoid because I am not a very, very large service provider that should be a transit path towards other ASs. I should only limit myself to the prefixes I own, the ones I want to originate in AS500, which is actually 10.1.0016, and the more specific ones 10.1.20 and 10.1.40. So obviously route map needs to be installed when advertising prefix out to my eBGP neighbors, but how do I match on those prefixes I want to advertise, filtering effectively the ones I don't? One way of doing this is obviously the access control list, another would be the prefix list with route map, and there's a third one. I can use AS path access list. So I've used already a regular expressions, IPBGP regular expression, and it's caret beginning with autonomous system and ending nothing in it. So that is limiting the prefixes I actually own and originate using network statements in BGP process. So how can I use that to my advantage in my route map? I can match on those prefixes using regular expression. And there's a special tool, AS path access list, which goes like this: AS path access IP AS path question mark access list, and there's number between 1 and 500. Let's go for number 1, and what follows is permit or deny statement. So that's something we already know how to do, permit, but here's the difference: align regular expression to match BGP AS paths. So if I want to enter something like question mark for incomplete, I would have to use Control V to actually create a question mark. Otherwise, it's going to display my help. But what do I want to match here? I want to match on the prefixes I own and I originate using network statements. And we already know what the regular expression for that is. It's empty autonomous system. This is the ones we advertise ourselves. So this is the matching mechanism. Now I need to do only route map, and let's call it AS500 underscore out. That's going to be name of a route map. In permit 10, I want to match on AS path number 1. So as of this moment, this route map is going to match on only a regular expression here, which is our own prefixes. This is the AS path. So obviously, I would have to kind of, let's just use maybe Notepad here. So in my text editor, I'm gonna create that route map because I need to apply this on all devices that's face external prefixes match AS path. So I would do this. And obviously I need to apply this to my neighbor. Now I have 2 neighbors, so let's just clear the terminal real quick and do show IP BGP summary. I'll go router BGP here 500. For my neighbor 10.1.10.254, I want to apply this route map in outbound direction. What am I advertising to that one? Show. So I'm also advertising prefixes I learned from AS100. I need to apply that as well. So if that's the case, I need to go back here, router BGP 500, and for neighbor 10.1.13.3, and the name is AS500 out in outbound direction. So if I do now clearing, and obviously I would have to apply this also on a router 2, if I do clear IP BGP for all neighbors, send my advertisements out one more time. If I do show IP BGP neighbor 10.1.10.254 advertise routes, now I'm only advertising the ones that belong to AS500. I'm no longer advertising 133.133. And the same thing here, show IP BGP neighbor 10.1.13.3 advertise routes. I'm doing only that. And I need to repeat the same process on R2 because R2 is also facing show IP BGP 10 neighbor 10.1.20.254 advertise routes. I'm advertising prefixes that were originated by AS30. So I'm going to go back quickly to my configuration and paste it in. Router BGP 500 for neighbor 10.1.20.254. Use route map, and this is the name of the route map out in outbound direction. Clear IP BGP 10.1.20.254 out, and if I repeat my statement, show IP BGP neighbor 10.1.20.254 advertise routes, I am only advertising prefixes that belong and originate in AS500 at the moment.